Okay, everybody, good morning and welcome to the third lecture in our online portion of the course. Today we're going to be talking about the problem of economic growth. So this chapter or this problem I'm going to be covering today is not covered in the book. So I will be using PowerPoint presentations as our guide from another book, and you would need to read anything in particular for this specific lecture. I will just post the PowerPoint presentation on Canvas after this lecture. That will be the only source that you need to consult for this problem, the problem of economic growth. Just consult the PowerPoint and watch this lecture, and it's reasonably easy. Topic I didn't want to go into some further complications and very detailed exposition. This is just a basic introduction to the problem of economic growth and how resources, technology, ideas, and institutions influence economic growth. So just sit back and relax, and you're going to be fine even without the textbook reading for this lecture. So let's start first by trying to define economic growth, and then let's see which factors can influence economic growth in a positive or a negative direction. So let's start with a few basic facts about economic growth, and then we'll deal with some further details of the theory later on. So the first thing you have to bear in mind that there is a difference between economic growth as a phenomenon in the long run. That's what we are interested here when we say economic growth. That's not a short-term fluctuation in economic data. Stuff that we discussed last time, macroeconomic fluctuations, recessions and expansions. Stuff that is happening on the short-term scale, 1 year, 5 years, even 10 years. So when we talk about economic growth, we are typically referring to a much longer period of time, 50 years, 100 years. So economic growth is a long-term phenomenon as a part of the theory. So how economic growth is to be defined? There are various ways of doing this, but usually we talk about an increase in real GDP from one period to the next period. This is called sometimes the absolute real economic growth. It means an increase in real GDP, and you will now remember that real GDP is best defined as the quantity of goods and services produced in a given country in a given period of time. So it's not nominal GDP that is not adjusted for inflation, but rather the quantity of goods and services that are produced in a certain period of time. Longer the time scale, more useful the statistics it is. So that's one idea there, the aggregate figures about real GDP. Another way of defining real GDP, defining economic growth, is to say that that would be a per capita real economic growth. So per capita means per person, per head, as we say. So that's an economic growth that is adjusted for the population changes, for the changes in the population side. So that's a real GDP that we divide by population. So one of the definitions that I didn't mention to you last time, I think, is that GDP per capita is the most useful measure of economic wealth of any given country. Real GDP per capita. Why? Because you can have a very large country, like China, for example, that can produce a great quantity of goods and services. And when you look in the absolute numbers, if you want to compare American and Chinese economies, and you use the figures of real GDP to make the comparison, you will find that Chinese GDP is larger than the American GDP. That means that the quantity of goods and services that the Chinese economy is producing is greater than than the quantity produced by the American economy. Does that mean that the Chinese are wealthier than Americans? No, it doesn't. Why? Because there is 1.5 billion Chinese and there are 320 million Americans. So when you divide the total numbers, total GDP figures for China by population, you get a much smaller number of real goods and services available to one person than in America. So that's the reason why real GDP per capita is a much more useful measure of economic wealth or the income level or the level of standard of living for any given country. Something similar applies to economic growth, to a change in real GDP from one point in time to another point in time. So let's say that the country's real GDP increases 5%, but the population increases 6%. Okay, so that would be essentially in real terms, a negative rate of growth of real GDP per capita, because you will have a much larger GDP figures for the entire country, but it will have to be divided up among even more people than before. So every single one individual person would get less than before. So a real GDP per capita, the rate of change in real GDP per capita is the best measure of how quickly an economy is developing over time. So you have to control for the changes in the population size in order to understand the economic growth. Now, do economic growth rates matter? So who cares whether the economy is growing 2% or 3%? It's just 1%. And then over 100 years, it's not such a big deal whether we grow by 2% or 3%. So that's an illusion. That's a very superficial way of looking at the problem of growth. And it is shown by if you use the formula for how the average doubling time of real GDP is calculated. So there is something called the rule of 70. That's a formula that says that you can calculate the number of years that a given country needs to double its real GDP. Okay? Number of years that a country needs to double GDP, you can calculate this number when you divide 70 by the average rate of growth of that economy over an extended period of years. So let's say that our rate of growth is 5%. Some country, India, has a rate of growth of 5%. And America has a rate of growth of 2% in the last 10 or 15 years or so. So now imagine that we continue, that both India and the United States keep increasing their real GDP by the same percentages for a foreseeable future. So now the question that you want to ask is how many years it will take to India to double its GDP, and how many years will it take to the United States. And the formula is simple: 70 over 5% gives you 14 years. That's the doubling time for India. 70 over 2% is 35 years. That's the doubling time for the United States. So you see that the difference in simple mathematical relationship, a simple mathematical function depicting the relationship between real GDP on the one hand and factors that can influence GDP, such as L, labor, K, capital, and T, which would be technological coefficient, which means how efficient, in other words, more labor you use, you're going to produce more. Of course, if you have 2 million people, 2 million workers, you're going to produce more than if you use 1 million people. Or K, capital goods. These are machines and tools and equipment and so on, and buildings that you can use. More of them you have, more, all other things being equal, more you will be capable of producing. Okay, however, the technological coefficients says that you can use all of them more efficiently, extract more output from the same amount of workers work using the same office space. That's the simplest possible example. Why this term T is introduced here? Technological coefficients. So technology increases productivity of both labor. Independent variables. Independent variables are terms on the right-hand side here. Those would be the things that you use to explain something else. Other things, and dependent variable is a thing that needs explaining. So in our particular case, here, production function is a function that studies how changes in technology, labor, and capital influence production or output, however you wanna put it. When we study the production functions, we assume that labor is fixed and that we can vary the capital, who is a production function. So now, obviously, if labor quantity of labor changes, if we go from L1 to L2, if we increase the number of workers, or if we convince the existing workers to work longer hours, obviously the quantity of output will increase. We will go from between the quantity of labor and quantity of output produced. So now you can keep increasing labor. If you don't change the quantity of capital goods and output, you are going to produce more output, but at a lower and lower pace. See, this is called the law of diminishing return. When you start from L1, amount of labor, you're going to produce Q1. Then you increase it to L2, you're going to increase the amount of output, but far less than before. If you increase it even more, the curve flattens here. So you remember that flattening the curve that they talk about these days in the context of the epidemics. Here, so the flattening the curve, that you have new people tested area of diminishing returns, that your output increases, but at a lot slower and slower pace. And eventually it becomes very low here at this point. For example, you can increase labor by the same amount as here, but your gain will be barely noticeable here. So that's known as the law of diminishing returns and has reasons why this is the case. I'm gonna assume just that intuitively you understand that if you don't change, if you imagine, for example, that you're producing wheat, that you're a farmer who is producing wheat, and you use labor, you employ one person, and then you employ the second person, and you employ the third person, and then you employ 10 of them, that your output is going to be increasing. But then if you don't increase the amount of other resources that you use in your production of wheat, the number of combine harvesters, the number of tractors, the size of your plot, the size of the productivity of every additional worker will be lower and lower, because you will first employ the person who works with combine harvester. Then you will employ a person to operate other machinery like tractors and other forms of machinery, and then engineer, and then the most important, the manual workers, and then after 6 or 7 person you may employ another one, but then the gains of this additional person will be much lower. In order to justify employing this additional person, you will have to invest in other things, for example, to buy another combine harvester or to buy another machine. So you will have to in order to retain the constant gains or to retain the constant returns on your labor investment, you will have to increase investment in other so-called complementary production factors, which means you cannot produce the entire supply of wheat or corn in North Dakota just by employing more and more people to work on the fixed plot of land with a fixed amount of machinery. You have to expand both the surface of land that you operate and the quantity of machines and equipment and fertilizer and all other complementary factors of production. So this is why this curve looks like it looks that returns diminish gradually if you change just one factor and keep other two factors, capital and technology, fixed. Okay. Another example, it's an even simpler example that I use is the corn stalk and flower pot. Imagine that you want to grow some corn in a flower pot, and you buy a flower pot with some soil in it and some fertilizer, and you plant your corn stalk, and then it grows, and then you want to increase the production of corn. You want a little bit more corn. So what you do? You can, for example, you decide to add a little bit more of Miracle Grow or more fertilizer. So more of this fertilizer will boost the growth of your plant, and you may get a little bit more corn. If you're not satisfied with that, you may increase it even slightly more. But then you cannot go forever just by varying one factor of production, just by increasing the quantity of fertilizer while not changing anything else. You cannot produce the entire supply of corn in the United States just by adding up more and more fertilizer into a single flower pot and then increase by 1,000 times, 1,000,000 times your corn yield. You will have obviously to buy another flower pot and another flower pot. You will have to add other factors of production and to plant more corn stalks in order to sustainably retain the rate of return from adding new units of fertilizer. Otherwise, if you confine yourself to just one single flower pot, you will very soon exhaust the productivity of fertilizer. You will enter the area of diminishing returns. So a sustained increase in productivity requires that the complementary factors of production, which means other resources, the cooperation of which is necessary for labor or for any one individual factor to increase productivity, you will have to increase them in sync. You will have to increase the capital and technology if you want constant returns of labor. If you keep them fixed, you will have this curve production function like this. Okay, so that's the reason why returns are diminishing. So remember, the law of diminishing returns means that for every combination of some fixed factors and one variable factor, there is always an optimal quantity, some optimal quantity of a variable factor, which is finite, which is limited. If you keep increasing your variable factor, the quantity of which you can change, beyond a certain point, you will get less and less output out of that combination. So returns will start diminishing. Okay, so this is the point of this production function curve here. It depicts the relationship between one variable factor and real productivity, whereas the two other factors are kept constant. So now, what can change this production function? If we assume that the production function is here, so you can increase labor while keeping the two other factors constant. You can produce more and more, but after a while it flattens out. The curve becomes flat, so you can by increasing labor from this point, for example, to that point, you're not gonna get much of additional output. So what can happen is actually that one of these two other factors changes. So for example, at point one, you may increase the quantity of labor, but then you may buy another combine harvester. So if you buy another combine harvester and you employ another person, now this person will not work uh, by operating a tractor, the contribution of which a job is less than if you have another combine harvester. So then the total value of output will be greater here at the level at the level of labor force employment L1 instead of Q1 you will have Q2. You will produce more if you have more capital goods, and then the entire curve shifts upward. Then if you have more capital goods, you will be able of producing with the same amount of labor much more than before. So this is a change. This is one of the ways in which you can shift the production function curve by increasing the amount of capital investment. Another way of doing the same thing is actually that you keep both capital and labor constant, but you change the coefficient of technological productivity, how much technology can derived from the same number of people working and from the same amount of capital goods, the same quantity of tractors, combine harvesters, houses, real estate, pieces of real estate, machines, tools, and so on. So if you improve your technology, your technological recipes, how you use factors of production, for example, by going from typewriter to a computer, you can increase your productivity way more with the same number of workers and with the same quantity of factors of production that you use. So American manufacturing is a very, very good example of that. Now that American manufacturing is producing much more than 50, 60 years ago, or even 3 years ago, but it's using far less labor than before. So how is that possible? That's possible because the production function of the American manufacturing economy has shifted so much upwards that eventually you can produce much more, shifted upwards because of a superior technology, automation, robotization, and so on. So then one single worker can produce much more than before. So then why American manufacturing output is going like this and American manufacturing employment is going like that? So these two are not in contradiction. When people say American manufacturing is declining, they essentially don't know what they're talking about. They're talking about the absolute number, the share of the population which is working in manufacturing, or even the absolute numbers of people who are working in manufacturing. But the manufacturing output is increasing faster than ever before. Why? Because the technological coefficient increased. Technological efficiency of the production processes increases dramatically, so then we can make much more stuff by using far fewer resources, capital and labor resources. So that's the key. This is the single most important fact in the theory of economic growth. This is one of the reasons why the entire world can, in the long run, grow sustainably by using fewer and fewer resources, by using a fewer quantity of raw materials and natural resources, why capitalism is sustainable in the long run, why we are not going to run out of resources in the long run, is that our technological processes become so much technologically efficient that we need less and less and less of steel, aluminum, wood, oil, coal, and so on. We need less and less resources, and we need less and less labor to create the same level of output as before. So our production function is constantly shifting upwards and upwards here. And the main reason, maybe the key, one of the key reasons, or maybe the key reason, is the increase in the technological sophistication of modern society. So you can increase production function by increasing the amount of capital goods, or you can increase technological capacity of your economy, or you can do both. How can you increase the or shift the production function by increasing the amount of capital? There are two ways of doing this, two direct ways of doing this. One way is through higher rate of saving. So what happens? You save more as a society. You will remember that income that every one of us, every one of individuals has, is always divided up into two principal components: consumption on the one hand, and saving slash investment on the other hand. And the same applies then for the society as a whole, for the aggregate of all individuals together. We have a percentage of our income that we in total spend on consumer goods now, buying stuff that we need to consume, and the amount that we save, which means not consume right now, save, and then through the financial system and banking system channel into, or directly use to invest in production of future goods and services. So imagine that, for example, we save now 10% of our income is saved that we use to produce. In this blue curve here is a curve that we can achieve if we save 10% of our income and we spend 90% of our income. And then let's say that we make a decision to change the composition of our income by saving 20% and spending only 80%. So our savings rate goes from 10% to 20%. Now, higher amount of saving will lead to higher amount of investment, because savings will be put in the banks, will be transferred or transformed into business loans. So these loans then will be extended to business enterprises. The interest rates will go down. Lower interest rates will make leveraging more profitable and more attractive to the businesses. Businesses will borrow more money in order to buy more capital goods, more machines, tools, equipment, and so on, to employ more workers eventually. So the increased rate of saving will lead to more capital investment, and more capital investment will lead then to higher number of machines, tools, and other capital goods being used in the production process, which will increase productivity of labor and which will increase our real GDP. So that's one thing, domestic saving increasing can shift our capital coefficient upwards and can create more production. Also, foreigners may invest more in our economy. If our economy is performing well, then the foreigners may decide to channel their savings into our own financial market. For example, the Chinese and Japanese are deciding to buy private corporate bonds or stocks in the American economy. They're increasing the amount of investment capital available to domestic firms. That's where the money ends up. So then domestic firms have more capital to buy machinery, tool, equipment, to employ more workers. So this will lead to a higher level of productivity with the same employment of labor. So the increase in capital investment can come from domestic sources, from increased domestic saving, or it could come from foreign direct and indirect investment, whereby the foreign savings are channeled or transferred into domestic production. So that's one way of doing it. The second way is through technological innovation and technological change. So then even if you don't change the labor hours or the number of workers, and you don't change your quantity of capital goods, you can increase your productivity simply by having more efficient, technologically superior uh, production processes or recipes. So here is the production of what happens when you move from one point to another point on the production function curve. Here that you increase real GDP, when you translate that into the aggregate supply curve, you see that this is a change, this is a shift to the right, shift of the long run aggregate supply curve. You will remember this, that last time we discussed, when we discussed macroeconomic changes, we've seen that aggregate supply is the total amount of goods and services that could be produced at any given price level in a country. So if real availability of factors of production, whatever happens, more labor, more capital, and so on, if production increases, if we move alongside this production function curve from left to the right, for example, from point 1 to point 2, this long run aggregate supply curve, that's the maximum quantity of goods and services that could be produced with 100% use of our resources, will shift from left to the right. So you see, higher technological coefficient, you can increase your total amount of goods and services produced by increasing the quantity of labor. This is going to happen. Real GDP increases. But the same thing happens if you increase technological efficiency of your economy. Then with the same amount of labor, you don't have to work longer hours anymore. You now have a superior technology that saves you labor. You see, you can achieve the same result, this here, by working more with the same technology and with the same quantity of capital goods. You can sacrifice more by working 10 hours instead of 8 hours. This is shift from L1 to L2. And you can have more output. But you can have more output, the same result essentially, by working the same number of hours, but with a superior technology, by using computers, for example. So this method of education, like a long distance education, wouldn't have been possible in the times without technology. The people video conferencing in the businesses, they are operating their businesses on 5 continents without necessity to travel every once in a while. So they can satisfy all their needs. They can coordinate their business decisions simply by talking via Skype or via whatever program they use for video conference. So you can have one manager in America, another in London, the third one in China, if they can agree about the time in which they make a conference call. They don't have to travel from one place all across the world in order to talk and coordinate their business operations. They can just use the technology. So then the amount of labor that could and the amount of capital that we use might be fixed. They don't have to work more, but they can produce more because technological efficiency has increased. You see, so this economic growth is of much higher quality than this economic growth here. Here you have to suffer, you have to work longer hours in order to have a given increase in output. Here you don't actually. Here you are in a sense free riding on the technological progress that somebody else produced for you. So I see that the increase in labor may lead to a shift in this aggregate supply curve. This is in production from Q1 to Q2. Now the question is, what can lead to an increase in labor? So people may work longer hours. So what may incentivize people to work longer hours. One obvious idea would be to lower personal income taxes or, for example, payroll taxes. So taxes are disincentives to work. So here you have the demand for labor and supply of labor. The blue line is the supply of labor, and the red line is the demand for labor. And we know in every market, the price and quantity of goods and services will be determined by the intersection of the supply and demand curves. So here L1 would be the equilibrium quantity. On the horizontal axis is the quantity of labor, or number of people times labor hours, quantity of labor that will exist on this market. And on the vertical axis is the wage rate. So then what's going to happen in order for you to secure more labor? What can you do? You can simply reduce the taxes. If you reduce the taxes, people will then be ready to work even for lower wages. Why? Because they will have more net income. Higher amount of money will accrue to them. So they will increase their supply of labor. If you reduce the payroll tax from 12.8% to 2%, I will have 10% more income available to me. So then I may be ready to work more than before, and especially personal income taxes, if they're reduced for higher income brackets, people will then. So this is known in economics that people tend to work much more when their tax burden is lower. So then the supply curve of labor will shift to the right. Then we will move from point 1 to point 2. So eventually the quantity of labor will increase from L1 to L2. And this is the shift here, from L1 to L2, and the productivity of the economy will increase. And obviously then the total supply of goods and services will increase. So then what can influence then? So that's labor. Taxes on labor income could increase the supply of labor in an economy. How capital formation can increase. So we've seen that already. So decline in interest rates that is derived from a higher savings rate can increase supply of capital, and also an increase in foreign investment can increase the supply of capital. There are other factors that can influence the production function curve. That's natural resources and human capital. So human capital is the knowledge and skills that person acquires through training, education, and experience. So you can have then a worker who is much better, and you can derive higher productivity, higher additional output from employing a highly qualified worker than by employing the unqualified worker. So that means that in the horizontal axis here, not all units of labor are equally good. So if you have a better trained and better educated labor force, you will derive higher quantity of additional output than with the lower qualified labor. Now, before 1970s, 1980s, this was the dominant view of how long-term economic growth occurs. So this was the so-called solo model of economic growth that assumed that the main way how you can grow is by saving more and sacrificing more right now. Working more, working longer hours, or saving a greater percentage of your income in order to transfer it into higher quantity of capital goods that you use in order to produce more goods and services. Technology was considered to be relatively unimportant. So technology was ignored. This is solo model or classical model of economic growth emphasized the influence of capital formation, quantity of capital goods. And the policy prescription then was that poverty is caused by a country not having enough capital to invest and to increase its production. Okay, so the lack of physical and investment capital was the main source of poverty. 1940s, 50s, 60s, 70s, that was the common wisdom. How to help poor countries in Africa, South America, and elsewhere was to transfer money, foreign aid, to transfer financial capital to these countries so they can create more capital goods and catch up with us, with wealthy countries. They can shift their production functions upward by increasing the amount of available capital. So they didn't have enough capital goods, they were poor, they were labor intensive, which means they used much more labor and much less capital to produce their goods and services. So they needed to become more capital intensive, which means that they needed to use much more capital goods and much less labor than before in order to catch up with the Western countries. So that was the idea, and the idea failed eventually, that this couldn't work. And the main reason why the idea of foreign aid as an engine of economic growth failed, there are two reasons. The first one is that it underestimated severely the influence of technology. So then it became obvious that you need to transfer technological know-how alongside the capital goods and investment. It doesn't matter very much how many tractors you do have, how many combine harvesters you do have, how many locomotives and railroad cars you do have, and other physical infrastructure, if you don't know how to use it, or if you use it in a suboptimal fashion, or if you don't have engineers and entrepreneurs who know how to use capital goods. So this transfer of know-how, technological and managerial know-how, became in 1980s and 1990s a very hot topic. So people realized that it's not enough just to give them the money, it's also enough to develop domestic, in poor countries in Africa, for example, domestic entrepreneurial and managerial elites who would know how to use technology and other forms of Western know-how, like the management of corporations. That's also non-tangible factor of production, how to organize the production processes. So you need this human capital and technological know-how in addition to physical capital goods in order to have a higher rate of economic growth. So that's one of the reasons why this traditional solo model of economic growth fell by the wayside. Now technology and knowledge economy becomes much more important. So this neoclassical theory, which emphasized just labor and capital, was abandoned, and now the emphasis is on ideas and technology and discovery and changing the ways how the businesses are organized and run, and changing the ways how technology is used in the production process. And the emphasis has shifted from the transfer of money in the 1990s, essentially, that the emphasis was strongly put on this. It's not enough even to have a technological and managerial know-how. You need to have institutions and the rules of the game that will encourage capital formation and investment and discourage corruption, theft, plunder, and economic disorder. It doesn't matter, it won't help you very much if you have the most sophisticated machinery and equipment and the most educated labor force in the world and the most sophisticated technology in the world, if you have 1,000,000% inflation rate, or if you don't have a stable structure of private property rights, if contracts were not enforced, if your government spending is 70% of your GDP, if your taxes are too high, then you're not going to grow economically. So then institutional theories of economic growth became very important and prominent in the last 20, 30 years or so. So you have first the neoclassical Solow model of growth. It says only labor and capital are important. Then the second generation was the you need technological know-how and managerial know-how. And then the third addition is this institutional theory of economic growth, which means property rights, contracts, low inflation, uh, a relatively low government spending, reasonable regulation of business. If you impose such a costly regulations that the businesses have to spend an inordinate amount of time and energy and money in order to comply with your regulations, they're not going to invest and produce in your country, they're going to move someplace else. So all of these factors influence how much investment and how much production will be. They influence your production function of your economy very directly. So growth promoting policies versus transfer promoting policies. What it means? That's one of the institutional, you see, legal system, contracts, property rights, and so on. Growth promoting policies, that's low taxes and reasonable regulations. If you transfer promoting policies would be government spending that penalizes entrepreneurship and encourages passivity and low labor participation and so on. Other institutions are also free trade, free international trade. So why free international trade is good? Because then domestic entrepreneurs can use the cheapest products and components in order to make them more competitive. So you may increase your production of domestic automobiles if you can buy foreign steel at cheaper prices than for example, artificially or naturally more expensive domestic steel. So then when Trump administration imposes steel tariffs, that suppresses the production function of American manufacturing sector because it forces us to buy domestic steel at higher prices and increases artificially the prices of imported steel, and that way reduces the productivity of labor and capital in the manufacturing sector and domestic economy. Taxes, regulations, educational systems. So all of these institutions in the wider sense of the word. So you shouldn't be thinking about economic institutions in a narrow sense of like political institutions, Congress or whatever, presidency, and so on. You should think of institutions in a way of a broadly defined rules of the game and elements of this socio-political environment that could be influenced politically and that can influence economics. So you see rules of the game in society that could be influenced by politics, but that influence economics. So those are institutions. Regulation, taxes, foreign trade, contract enforcement, private property rights, all of these things that I enumerated here could be influenced by politics, could be either protected or undermined by politics, and all of them influence economics development. So depending how well you get these institutions, how well you fix them, how well you develop them, then your productivity of your economy will increase as well. And that's the end of today's lecture. So with that in mind, I invite you once again just to put your questions on Canvas, on the discussion section that I created, any questions that you might have about this topic, and I will be more than happy to answer them in due course as another short video. And I will post immediately after this lecture, I will post the PowerPoints that I used here as an illustration of this important topic. So bye bye for now, and I'll see you again on Thursday.